Here I am taking some basic formulas from differentiation, and these formulas will help those students who are going to revise the calculus, and this will help you who are dealing with calculus. Okay, let's see. Here d by dx of x to the power n, which is equal to n into x to the power n minus 1. Okay, for example, d by dx x to the power 4. This type of questions you can face. What is the answer of this question? This is 4x cubed. 4 is the value for n, x is the variable, and 4 minus 1, so 3. Your answer will be 4x cubed. Okay, now this one, x to the power minus 3. So minus 3 is here your n. So n x to the power minus 3 minus 1. This is how we will apply this formula. You can see this one, so x to the power half, or half x to the power half minus 1, whatever the calculation. But this kind of functions can be differentiated using this formula. Okay, then again d by dx of 1 by x cubed can also be used this formula. How? It is actually x to the power minus 3. Okay, next you see d by dx of a to the power x. So it looks like same, but the difference is that here this x and this x both are same. The variable of the function, the variable with which we are going to differentiate, both are same. And here variable of the function is used as a power, but base is constant. That's the main basic difference between these two functions, right? This is x to the power n and this is a to the power x. That is why these differentiation are different. This is equal to a to the power x log a. A is greater than 0. Why? Because logarithmic function is defined only for positive real numbers. That is why a must be positive. Even a cannot be 0, because this function is entangled with logarithmic function. That's why. Okay, now here you can see d by dx of 2 to the power x. This, you see, a is used as numerical value, that is 2, right? Positive real numbers. And x, this is used as power with which we are going to differentiate. So in this case, in this kind of differentiation, we will use this formula. Okay, you can see 3 to the power x also. What is the answer of this differentiation? Using this 3 to the power x log 3. 3 is greater than 0, obviously. So we can work out this kind of problems following this formula. Okay, now d by dx of e to the power x. So this is e, actually a constant. It is a numerical value like this. So e to the power x is a special form of this differentiation. Here you see a to the power x log a is there. So if you follow this formula to work out this, then we will write e to the power x log e, and log e is equal to 1. So that is why this is equal to only e to the power x. Log e is not necessary to write here because it represents only 1. So d by dx e to the power x equal to e to the power x. This is the only function whose output is also after differentiation remains same. Okay, then the d by dx of log x is 1 by x, where x is positive real numbers. This one. So log is defined only for positive real numbers. That's why x is positive. Okay. Now you can again revise this. D by dx of x to the power n. What was here? N x to the power n minus 1. Again you try d by dx of x to the power n is equal to n x to the power n minus 1. Okay. Remember this. D by dx of a to the power x is equal to what? Can you answer this? Yes. This is a to the power x log a, where a is positive. Again you try. What is this? A to the power x log a positive. Okay. Now come to this formula. d by dx of e to the power x. This is e to the power x. Okay. This is 1 by x. X is positive. Fine. Remember all this. d by dx of n x to the power n minus 1, d by dx of a to the power x log a positive real numbers, d by dx of e to the power x, and d by dx of log x 1 by x, where x is positive real numbers. Fine. Let's move. Now n x to the power n minus 1. What was the function whose differentiation is this? Now let us find the question actually. N x to the power n minus 1 is obtained by differentiating x to the power n. Okay? Can you recall it? Yes. d by dx of x to the power n. So similarly here, d by dx of which function? A to the power x. This is how you can remember. d by dx of e to the power x. This one. And this is d by dx of log x. Let's move. d by dx of c. This is, c is a constant. It is always 0. Here you can put any number, 7, 8, any constant. Differentiation of any constant is always 0. Now d by dx of c constant into any function. In that case, c will be taken out. Right, this is very important, the differences between this constant. Here constant is differentiated, that's why it is 0, but here this constant is along with this function, so it is taken out. This c cannot be 0. Okay, c, this is d by dx of fx, or we can write f dash x. Okay, c f dash x, right? Now for this you can see this one, differentiation of constant function. See, d by dx of 4 0, d by dx of minus 7 0, but here the x cube and 2 is also there, which is constant, but this 2 is taken out, and the x cube 3x to 3 minus 1, 3x square, applying x to the power n. Okay, so 2 is taken out, and that is what is explained here. Fine. Now d by dx of sine x. All these are trigonometric ratios. You see, sine, cos, tan, cot, sec, cosec. So d by dx of sine x is equal cos x. Okay. Differentiation of sine x equal to cos x. Okay. Now differentiation of cos x, sine x, but this minus sign, remember. Okay. Then d by dx of tan x. This sec square x. Remember, cot x minus cosec square x. Okay. d by dx of sec x. Start with sec x. Here you see. Then tan x. Sec x tan x is the differentiation of sec x. Now here again we will start differentiation of cosec x. We will start with cosec x. See. Then cot x. But there is minus sign. Okay. Now here cos x is minus sin x, cot x minus cosec square x, cosec x minus cosec x into cot x. Okay. See, these three formulas have negative answers. Output is with negative sign. Okay. But the rest are positive one. You can see there, sin x, positive cos x, tan x, positive sec square x, sec x, positive sec x tan x. Fine. Just remember all this. Let us check again. Okay. Sin x plus cos x, and d by dx of cos x minus sin x, d by dx of tan x, sec square x, d by dx of cot x. Here minus sign is there. Where there is a c, you see c minus, c here minus cosec square x. Now again here cosec x, c is there, minus cosec x cot x. So this is how you can remember where there is a c in the function, there is minus sign in the output. Okay, this is one kind of technique actually, right? And sec x is equal to, you start with sec x, tan x. Okay, now we will check with reverse process, cos x d by dx of sin x, right? Minus sin x, it is cos x, sec square x, it is tan x, differentiation of tan x. This is, as cos x square x is obtained differentiating which function? Cot x. Now sec x tan x, only sec x. Remember, differentiation of sec x starting with sec x into just tan x. Remember this function, sec x tan x. Then here cosec x means d by dx of cosec x, you see. Okay. Now antiderivative means, now antiderivative is represented by integration sign. We will see integration of cos x dx, this is sin x. So integration x is actually a reverse process of differentiation. If you know differentiation, then you will be able to learn integration also. Here I just mentioning here to help you, so that if you know this, then integration can also be learned simultaneously. That is what I am going to say here. Okay, but this cu is constant of integration, and you will learn it later on when you are going to start integration. Okay, right now you just remember that antiderivative is the opposite of differentiation. So d by dx of sin x is equal to cos x. It implies integration of cos x dx is equal to sin x plus constant of integration. Fine. Now here integration of sin x, but this negative sign will be here now. See, integration of sin x minus cos x, this minus sign will go there. Here, can you make the formula? Integration of sec square x dx equal to this tan x. Now next, cosec square x, this negative will be here, minus cot x. The integration of sec x tan x will be sec x, right? Then integration of cosec x cot x is minus cosec x, this minus sign will go there. So this is how integration and differentiation related. You got some idea. Cos x is obtained the differentiation of which function? Can you tell me? D by dx of, yes, sin x. Here d by dx of cos x. And this one minus cosec square x, d by dx of cot x. This sec square x, can you remember? It is d by dx of tan. D by dx which function is equal to sec x tan x? Can you remember? Yes, you are right, sec x. Then here d by dx of cosec x, exactly. So this is how you can remember or recall your formulas. Okay, let's see. These are all for inverse functions. Here very interesting point is that all these 6 formulas can be remembered by knowing only 3 of these. So how? You see here, d by dx of sin inverse x, 1 by root over 1 minus x squared, right? And d by dx of cos inverse x is the same function, this one, with a negative sign just. You see, this one. Everything is same except this negative sign. So if you remember sin inverse x, then this is very easily we can remember, isn't it? So this can be remembered with the help of sin inverse x. So that is how with these 2 are related and these 2 are related. So 3 of them are enough if we remember. See this one, 1 by 1 plus x square, cot inverse x is minus of 1 by 1 plus x square. Okay, sec inverse x, this is 1 by mod of x, root over x square minus 1. I am not talking about derivation, right? Just how to remember and what are the formulas, that is all we are discussing. Okay, Cosec inverse x, just put negative sign. So this is how you can remember all this. Just you remember these three. Rest are here. Just put negative sign, here negative sign, here negative sign with this. Okay. So remember this one. What is here? 1 by root over 1 minus x squared. Okay. Then this one with minus sign. Okay. 1 by mod of x root over x square minus 1. 1 by mod of x root over x square minus 1. 1 by mod of x root over x square minus 1. Okay. I think you remembered this. And this is 1 by 1 plus x square. Here it is minus 1 by 1 plus x square. This is same, minus 1 by mod of x root over x square minus 1. Okay. Now this is product rule. Means if we have to differentiate product of two functions, u into v, then how will we operate it, isn't it? So here, see, v d by dx of u. V means second function is left without differentiation, and we are going to operate the first function d by dx of u. Okay. Then plus u d by dx of v means here second function is left, first function is differentiated. Second is left, first is differentiated. Now here first is left, second is differentiated, and then this plus sign. So this is how you can differentiate product of two functions. Okay. Now this is quotient rule, division. Two functions are there which are in this form, p by q form, means u by v. Then how will you differentiate, isn't it? Let us begin. So see, v denominator, denominator square. Start with this v square, then next v d by dx of u, v denominator square, then again you start with denominator, remember that. Then d by dx of this numerator, this u, and next minus, not plus. Okay, only plus is there here in case of product. Now in case of division we will get here minus sign, right? And then the other part is same with this. You can remember with the product rule also, with the help of product rule also. See, both are, all these things are same except this plus sign, right? This is numerator divided by denominator, means p square. Okay. Then generally, if f u composition vx, composition of two functions are here, then how will you differentiate this? Here u composition vx. Now you start df by dx with respect to x, because f is a function of x. Okay. Then du by dt. Where will we get this t? T is considered as a function of x. Vx is considered t. Then dt is to be differentiated with respect to x, where t is equal to vx. This is considered actually. ut, we have made f is equal to u of t. U is a function of t and t is a function of x. Means in a composition function we always consider another variable, and with that variable we will work out the differentiation we call chain rule. Okay. Now you see d by dx of sine ax plus b. Instead of sine x, here this is a composition function, sine x and ax plus b. So ax plus b is to be differentiated. This is suppose sine t, right? So we will use here chain rule to differentiate. But now I am going to give the formula only here, sine ax plus b. So then what will be the answer? A is this coefficient, and then cos ax plus b, because d by dx of sin x is equal to cos x, that is what? Cos ax plus b, and differentiating this t, dt by dx, so we will get a only, because b is constant 0, right? So this is how we will get these formulas. Now next, d by dx cos ax plus b, this is equal to what? Minus sin ax plus b with this a, right? Next, tan ax plus b, sec square x plus b, but with a sec square ax plus b. Next you see d by dx of cot ax plus b. Can you guess what will be it? This is a cosec square ax plus b. Just put this a only in this kind of formulas, right? The next, d by dx of sec ax plus b. It is begin with sec ax plus b, tan ax plus b, like previous one, but with a sec ax plus b, the next tan ax plus b. Fine. Okay, d by dx of cosec ax plus b. You start with cosec, but with a, and cot ax plus b. These are the basic formulas for differentiation, and you must know this. I have already shown you that these are interrelated with integration, so I hope you will pay your attention to all these things. Okay, thank you.